Hello everyone. I wish all of the things is good for your life. Thank you very much for coming here. We will try to show something theoretically and practically as best as we can. Big data is actually one of the subjects that is a little challenging for everyone. But when it's understood, it continues to be a very valuable and critical field where you can do many things easily. And if you specialize, I should also point out that employees who can combine cloud and big data are generally more successful in finding complex solution methods. So let's get start my presentation. I am Hakan. I have almost 10 years experience in the IT sector. My major area is the software testing sector. I'm currently working the developer technical support engineering team, and I work in the cloud area in here on the engineering manager status. While my expertise is on the big data specific, and I learn domain specific learning path in that team. My fundamental research based on the big data, and my concentration is in here. So we will get started to this content. First, I will give information about the big data basics, intermediate level, and after I will talk about the Huawei Cloud Big Data Services. And third topic, I will give my speech to Elif, and Elif made a demo. This demo is the hands-on, and the subject is the using Flink job to process OBS data on the Huawei Cloud. At the end of the hands-on demo, we will wait your questions. If you have, and we will wait your answers and live on. If you watch in the future, you will be sent mail for our corporate mailboxes. First, let's examine what big data is. Big data is the increasing volumes, reach very high levels, and contains a lot of diversity. It includes the concept of the velocity, volume, variety, velocity, and value, which will be examined shortly. So basically, big data is the complex and the large data sets. These data sets are the so voluminous that we cannot process this data with traditional methods. However, this high volume of the data can provide us the prediction if it can be analyzed well. Big data analysis help organizations that can accurately evaluate the data on real customer behavior and turn into the high beneficial tools. So I will explain this 5 characteristics of the big data. Big data is the collection of data from many different sources and is often described the 5 characteristics. I think let's describe. So first one is the velocity. Velocity is the speed that which companies receive and store and manage data. For example, the specific number of the social media post or search queries received within a day, hour, or other units of the time. The volume side is the size of the amount of the big data that companies manage and analyze. On the variety side, the diversity and range of the different type of data, including unstructured data, semi-structured data, and the raw data. Veracity is the truth of the accuracy of the data and information assets, which often determines executive level confidence. Value, this is the critical things. So the most important V from the perspective of the business, the value of the big data usually comes from the insight discovery and pattern recognition that leads to more effective operations, stronger customer relationship, and other clear and quantitative business benefits. Data flow must be continuous and in the large volumes. Data volume and speed are growing exponentially every day. Therefore, Data needs to be processed in the real time and converted into the information. This presentation includes a big data massive amount. You will see that every day we feed Facebook database with mounts of the information, Every 60 seconds, 136,000 photos are uploaded, 510,000 comments are posted, and 293,000 status updates are posted. That's a lot of data. At first, this information may not seem to be mean very much, but with data like this, Facebook know who our fans are, what we look like, where we are, what we doing, our likes or dislikes, and so much more things. So researchers even say that Facebook has enough data to know better than our therapists. That's interesting. So we will go on the characteristic of the big data for 5V. Most of the data processes has different formats, from phones, tablets, computers, etc. Data coming from the different operating systems or language results in the different formats. So first one is the structured data. Structured data is the tables handled by relations databases. Unstructured examples are generated by the humans, must be processed into the data gain value. And the last one, the semi-structured data, has some structures but change with the documents. Something like that, HTML, XML, JSON files, log files. Developers know these things. So we can move on to Hadoop side. So we will talk about how we can handle the big data on the tools. Our first topic is the Hadoop. Hadoop is the popular open source Apache project developed with the Java programming language using the MapReduce programming model. This software, which is available through the Apache open source license, enable secure and scalable information processing by being responsible for the methods such as low cost, fault tolerance, load balancing, data distribution, and processing. So we can briefly say it big data processing system. With more, Hadoop implements distributed file system and MapReduce algorithm by dividing the large query into the many parts, sending the relevant parts to many different nodes, and then combining the result from each node. In this aspect, it can be said that it is a very good architecture for processing for big data. Hadoop services provide for the data storage. This is the important point. Data processing, data accessing, data governance, security, and operations. Therefore, the load will decrease and the processing time will also be shortened. That's the critical point for the big data employees and the operations. Apache Hadoop can be divided into the two main parts. HDFS, known as a distributed data systems, is used as a storage part, and MapReduce as a processing module. HDFS, one of the basic building blocks of the Hadoop, is a self-healing distributed file system that can provide fault-tolerant, reliable, and scalable data storage. Since it supports distributed storage structure, it works in a conjunction with the MapReduce in a storage and calculation related operation. Even by combining of the disk simple service, it can create a large disk space and offer a more cost-effective solution. HDFS accepted all types of data automatically, optimized data while providing the high bandwidth. One of the most important features HDFS is the fault tolerance. In case of the failure is the node of the distributed file system, it ensures the transfer of the data and allows the service to continue. This structure is similar to the RAID structure and prevent the data loss. This is the HDFS architecture of the sheet. So Hadoop is divided into the two parts. When I said before, HDFS and MapReduce side. HDFS is the store data, MapReduce is the processing data. If we talk about the architecture of the HDFS, we can say that it consists of the basically 5 services, as you can see in the diagram. The first of these is the name node. Name node is also the master node. Master node protects and manages the data nodes. It keeps the metadata of all the nodes in the cluster. For example, the location of the source block, the size of the files, etc. Apart from this, it's the regular heartbeat and block reports from the data nodes to check whether the data nodes are still alive and healthy. And it keeps the track of the which nodes are the blocks HDFS are located on. Another one is the data node. Data node is the slave node. Real data is the stored blocks within the data nodes. And they also send the heartbeat to name node every 3 seconds. Apart from these, there is also secondary name nodes. Secondary name nodes work simultaneously with the primary name node and accelerate the background, but we cannot say the secondary name node is a backup name node. One of its function that is continues to read all the file, system and metadata to name nodes, RAM, and to write them to the hard disk or file system. Additionally, the HDFS structure includes the job tracker. Job tracker receives the request from the MapReduce from the client, retrieves information from the name node to know the location of the data during the processing. Finally, there is a time tracker, task tracker in this structure. This is a slave node running for the job tracker. It receives incoming task from the job tracker. MapReduce is the programming model of the pattern within the Hadoop framework that is used to access the big data stored in the Hadoop file system. It's a core component integral to the functioning of the Hadoop framework. MapReduce facilitates the concurrent processing by splitting petabytes of data into those smaller chunks and the processing them in the parallel on the Hadoop commodity servers. In the end, it aggregates all the data from the multiple servers to return the consolidated output back to the application. For example, a Hadoop cluster with a 20,000 inexpensive commodity servers and 2056 megabyte block of the data for each can process around the 5 terabyte of the data at the same time. This reduces of the processing time as compared as a sequential processing of the large data set. MapReduce was the only method through the which data stored in the HDFS could be retrieved, but that's no longer that case. Today, there are only query-based systems such as Hive and Peak. There's a lot of users that retrieve data from the HDFS using like the SQL-like statement. However, this is usually run along the jobs that are written in the MapReduce model. That's because MapReduce has the unique advantages. At this point, Hadoop works in the advanced system architecture. It ensures faster processing at the same time by distributing tasks of the data for the different clusters. In addition, collecting, analyzing the processing data results are among our features. So we will move on to MRS architecture. Here we can see the MRS architecture. As I mentioned, MRS is the platform where we can get many big data solution service with a single click. By deploying cluster in the MRS that contains resource to meet requirements of the work we can carry out. MRS provides us the convenience and the big data solutions on the Huawei Cloud, scalability and time advantage for these services. In previous topic, we saw the Hadoop, which is responsible for the processing and distributed storage of the large data. However, since the data solution is the Hadoop are expensive, inflexible, take a long time, and stand up very slowly. But Huawei Cloud has developed a service provider like MRS. Within MRS, we can deploy the Hadoop clusters and use multiple big data solutions for provider for one click. That's the critical point of that. We can give Storm, Hadoop, Spark, HBase, and Kafka example of this providing. So we can move on to Apache Spark. Is the open source cluster computing framework that's the real-time data processing. The main feature of the Apache Spark is the memory cluster computing, which increases the processing speed of the application. Spark provides an interface with implicit data parallelism and the fault tolerance and the scheduling entire clusters. It designed to cover a wide range workload, including the batch applications, iterative algorithm, and interactive queries of the strings. So when we compare the Spark, it's a very advantageous tool. So it's a fast Spark, run to 100 times faster than the Hadoop MapReduce, so which is used to large-scale data processing. It can also achieve the speed through control the partitioning side. Caching side is the very critical for the persistence capabilities, and the real-timeness offers real-time calculation, and the low latency is the affect the memory calculation. So the last one is the language support, because the Spark provides the high-level APIs for the Java, Scala, Python, and R. You can use the Spark, any of them, these 4 languages. We can move on to Apache Flink. Apache Flink is the computing framework that supports the both batch and streaming processing. It has various components such as a task manager and job manager. Job manager is briefly responsible for the coordinating the distributed execution of the Flink application. It schedules tasks and reacts to completed task or execution failures. It has various duties like this. Another component is the task manager. Task manager also has the workers carry out the task on the data flow. Finally, Flink client's functions send streaming for the Flink. Some of the main advantages of the Flinks are it can be worked the file system other than Hadoop file system. It provides easy API support. It's the open source. That's the critical point for developers, providing a better testing capability and support. And this is extremely fast for the data processing ability, because it is fast because of the runs on the memory. We can say the Apache Kafka is the open source distributed event streaming platform that's used by thousands of the companies, high performance data pipeline streaming, analytic, data integration, and the mission critical application. It have a core capabilities are the high throughput, this is scalable, permanent storage, and the high availability. On the ecosystem side, built in the stream processing, connect to the almost anything, client library side, and the large ecosystem to open source tools, the important for the Apache Kafka. We can move on to Apache Flume. Flume, it's the distributed service that streams the large amount of the log data. Flume operating structure, Flume works as a Java application called agent and has a 3 interconnected structure. The name is the sources, channels, and sinks. Source is where the logs come from the Flume. Channel where the logs will be located in Flume, and the sink where the log will be written can be summarized as. In the most basic form, and the agent setup with the one source, one channel, and one sink works to the receive logs from a single point and to write them a single places. It's possible to build complex models by the running more than one channel sync or more than one agent. In this diagram above, events created by the external source, something like web servers, are consumed by the Fluent data sources. The external sources send events to the Fluent sources for in the format recognized by the target sources. Here we observe a working system in which log is the data retrieved from the many sources are processed through the Flume and stored here in the HDFS and HBases. We can list the reliability, scalability, easy management as a service of the user in the Flume. Although Flume usually writes data on the central storage, such as HDFS and HBase, we can configure the Flume according our need that so that sync can write the data from another agent. So we can move on to Apache HBase. HBase is the column-oriented, non-relational database system that run off the HDFS. HBase is to provide the fault-tolerant way to store sparse datasets, which is the common in the many big data use cases. It is the well suited for the real-time data processing or random read-write access to in the volume of the data. Unlike the relational database system, HBase does not support the structured query language, something like SQL. In fact, HBase is the non-relational data sources at all. HBase is the application are written in the Java, like a typical Apache MapReduce applications. Support writing applications, HBase is the Apache Arrow, REST, and Thrift. I think Thrift is adding the latest one. And HBase system is designed to scale linearly. It consists of a set of the standard tables with the rows and columns, much like the traditional databases. Each table must have an element defined a primary key, and all the accesses attempt to do HBase tables must be used the primary key. Here we can clearly see the applications of areas of the HBases. HBase is the functional in the field for medicine, commerce, and sports. It generally uses the store and process that data in this area. We can move on. This is the final tool that is the Hive. Hive is a data warehouse infrastructure tool that processes structure of the HDFS, making it easily the query and analysis. Hive uses SQL and as a query language as a HiveQL, perform ad hoc queries, and however, it's not a relational databases. After giving general information about the big data, we can now start by taking a look at the Huawei Cloud Big Data Services examples. The order of the explanation will be in here. So firstly, I will introduce the DWS. This is something like named the GaussDB. And the second one is I explained the DWS architecture and examples. So we can move on the DLI, Data Lake Insight introductions, and give an example about that. So I finally compare the services, and after that I will give my speech for the Elif. I think we move on to DWS. What's the data warehouse? Data warehouse is the system used to storage and to report data. Data, from the various sources and is stored in the data warehouse for the long term, and the storage after and analysis after going through the extractions and transformation processing, like ETL. The data kept in the data warehouses can be accessed when necessary, and analysis and reporting can be performed. In other words, data warehouse are a structure that help companies make a decision. Data warehouses, unlike databases, historical information. In data warehouses, data can only be read, deleted, and updated. Only data loading and access operations can be performed in the data warehouses. So, why we use the DWS? Because we are talking about the highly scalable, reliable, next generation cloud of the data warehouse. So, the first one is the cluster are highly scalable with the tens of the petabytes of the storage capacity. It can fast and can meet the SLA's requirement with the multi-layer parallel computing capability. Data warehouses operates 7/24 guaranteed by multi-layer, high availability and backup and full hardware redundancy. So second one is the feature of the responding to the large concurrent request with a seconds. One cluster, 480 nodes and 20 petabytes of the storage capacity. We can say that it's very useful for the data analysis, data market, and BI transactions. Because GaussDB can respond to highly concurrent queries in the second, even the milliseconds. It also uses the resources have a speed up for the parallel calculation. So we can move on to lakehouse of the scalable HTAP workload. This is about to handle the more than 1 million QPS and 100,000 TPS with the strong consistency. Resources are dynamically allocated between the tasks based on the priorities. This is the critical point of this database site. So clusters can be flexible, scale the accommodate workload peaks. At the same time, GaussDB can read and write directly from the object storage by separating the cold and hot data. The feature I'm talking about, the hot data and cold data, is in general, hot data requires the fastest and the most expensive storage because they are accessed the more frequently. Data that accessed the less often is called the cold data and can be stored in the slower and cheaper environment. This data is very according to demands and the needs and the companies. So last of that is the faced in the data source integration and complex ad hoc queries is the complex SQLs combining more than 10 tables in the second. Up to 600,000 records can be imported per second, and analysis the results can be obtained in a short time. Various data sources can be conveniently integrated and managed. This is the advantage of the big data. So we can see this 5 bullets of that. I suggest this 5 of this is the critical. So I think usage of the data warehouses importance in here. I want to say DWS architecture of that. So I explained the upside down. So firstly, I want to say application layer. This is the data loading tool, extract the ETS, BI tools, and data mining and analysis tools can be integrated with the GaussDB. If you want to modify things, this seems very easy. So interface side applications can connect to GaussDB via standard JDBC 4.0 and ODBC 3.5. And after that, MPP cluster side is the same structure in the same subnet. This node jointly provides services. Data nodes in a cluster store data on the disk. The coordination node, like CN, receives access requests from the client and returns execution result. Then the CN divides each task into the several smaller tasks assigned to the DNS for execution. So automatic backup, cluster snapshots can be automatically backed up to object storage service and the event branch sites for the level object storage service that facilitated periodic backup of the cluster during of the peak hours and the recovery of the data of the exception occur. Snapshot provides the complete backup that records of the points in the timeline configuration and service data of a data warehouse. On the right side, toolchain side, it provides the Gauss DB parallel data loading, something like GDS, SQL syntax migration tool, this is something like DCS, and the SQL development tool, something like Data Studio. This is our console screenshot. This screenshot was taken from the Huawei console. Here, the steps which these operations will be carried out of the actual state, written with the explanations on the console to make it easier to use. On the left side, this is the access of the Gauss DB. On the left side, left picture, user login this process on the DWS console side. They will be reached the login credential. And the right side, we will be use the JDBC ODBC connection to type to reach the clusters on the DBS. After the reach the system, we will be get to the data with the two different way. First, on the left side, we will be reach the services like OBS and MRS. You will be see that in the presentation. So we will load data on the DBS cluster. And the right side, for example, we have external data sources and connect the data sources with the CDM and import the data inside the DBS cluster. After all data is come from the DBS cluster and it works successfully, and we will analyze the data and see the results. On the right side, we will see the progress of the data processing and the data storage and the data analysis and the data visualizations of the Huawei Cloud. This is the example of the data warehouse migration. The data is taken from the existing data warehouse, whichever DB or DBs are used in your company. These are made ready to migrate. After this progresses, the data is coming to DVS, is entered into the progresses in the DVS, and after that, the relevant operations are carried out here. The transactions are completed with the BI and the reporting section, the upper layer. I want to give example about the converged big data analysis site, and made lots of different features in here to the offline and real data processing on there. You will be see which industry is available and use which data types will be used on there. You will be see the top of the screen. So I can move on. This is the real-time data analysis example. IoT supports a structure used in the finance, education, and mobile internet, and the online to offline, O2O industries is available for the big data site. This is the related service for the DWS, and this is the work with and help infrastructure of the installation. For example, I want to explain the IAM site. IAM is the Gauss DB used as an identity and access management for authentication and the authorization site. Users with the DVS administrator permissions can take full advantage of the Gauss DB to obtain permissions, contract with a user with security admin to permissions, or directly create user with the DWS administration permission. Users granted the DWS database accesses permission can create the temporary databases, user credentials based on the IAM users to connect the database into the data warehouse clusters. So we can The comparison is to show the advantages of the Gauss DB. So we can clearly say that there's the four advantages, at least four advantages of the Gauss DB. This is the efficiency, scalability, storage, and reliability side. Most critical things is the scalability side, I think. Because you cannot do 15 read replicas as well as the scale the CPU and memory capabilities for the database instance as needed. I want to say the data lake inside this is the Huawei Cloud Services, Big Data Services example. Data lake inside is a serverless data processing and analysis service that is fully compatible with the Apache Spark, Flink, and OpenLooking. This is the Presto based. So ecosystems you can use stream analysis with the standard SQL, batch analysis with the Spark SQL, and interactive analysis with the Flink SQL. The query common data formats without data ETL. DLI supports the SQL statement and the Spark application for the heterogeneous data sources, including the cloud table, RDS, DWS, CSS, OBS, private databases in ECS, and offline databases. Offline database is the critical point of that. We can move on to why we can use the data lake inside, because DLI allows to easily explore the terabytes of data in your data lake in a seconds with the zero OM overhead using standard structured query language is said that SQL. This is the critical point of that. So I want to say the cross-source connection is the critical thing of that, because the DLI data sources connection provide the easy data access between the sources and collaborative analysis. No need the data migration. This is the 5 advantages of the critical bullets for this service. I said before, this is the full SQL compatibility. Do not require the big data to do big data analysis. So if you know the SQL, so you are the good and you will be manage that. This is the high availability side is the important. Third bullet is about the IAM side. So last of that, the availability with the dual AZ deployment is the critical point of this services. So here we go. This process is divided by the 4 step. Firstly, you will buy it, and after you prepare your data or our cloud or external site, and after you create a Spark job and manage it on the console. After that, we can see the result of the execution. This is available for the export the meaningful results. I want to give an example about the DLI site for the database analysis. Database analysis application data stored in the relational databases need to be analyzed, extracted more value. For example, big data obtained for the registered transactions helps in the business decisions making. In advantage side, SQL experiment transferability, because DLI supports standard SQL 2003 standards relational database syntax. So there's virtually low learning curve. This is the critical, because if you have a learning curve, you will be more hard to explain and understand the things or something like that. It has versatile, robust performance, distributed in the memory computing models, effortlessly handle complex queries and cross-partition analysis and business intelligence processing. The second example is the relational analysis. It combines information from the multiple channel to improve conversational rates. This advantage the cross-source analysis at CTRs, maybe the social media interact this presentation. especially in that page. So data stored in the OBS and the user registration data in RDS can be directly queried without switching to DLI. SQL only required interconnected data sources are mapped together into a table created using only SQL statements. Our third example is the permission control. This is the granular permission management, improve the data security and the operational efficiency when multiple departments need to manage resources independently. Disadvantage of that, the easy permission assignments, grant permissions by the columns or by specific operations such as insert into, override, something like that, and set metadata to read only. Unified management as a single IAM account manage the permission for all staff. This is the most critical features of the permission control side. I want to say the related services for the DLI, and this is the work with the health infrastructure installation. I want to introduce how can relate with the OBS services. OBS works as a data sources and the data storage system for DLI and offers the following capabilities, something like data sources. DLI provides an API for you to import the data for corresponding OBS paths to DLI tables. Data storage side, you can create the OBS tables on DLI. However, such tables only store metadata, while the data content is stored in the corresponding OBS path. Data backup, I want to say this is the advantage of the things. So DLI provides an API for you import the data for the DLI to OBS for the backup. The latest one is the query result storage. DLI provides an API for you to save routine query result data for the OBS. I want to compare between the data warehouse and database because this is the more confusing in our mind. A data warehouse essentially supports the enterprise decision of the analysis and related operation focus on the data querying. Therefore, it increases query speed and reduces total cost of the ownership. This TCO, maybe everyone knows these names, by optimizing table structures and the storage modes. That comparisons have a lot of different titles, but based on that, these features are the essential one. On database side, this is the mini summary for the Huawei Cloud. On database side, we divided this area into two sections. This is the relational database relational database server, RDS, Gauss DB for MySQL, Gauss DB for PostgreSQL, RDS for the SQL server. Second one is the non-relational databases. This is the DDS or Gauss DB for NoSQL, including the Influx, Redis, Mongo, and Cassandra. Data warehouse side is the DWS. Data lake or lakehouse include the MRS and DLI. Latest one is the data governance center, the Data Art Studio. I will give my speech for the Elif because this is all my part. We can move on to, I think, break time. And after my colleague Elif will be going on the hands-on section. Thank you.
Hello everyone, let me share my screen. I hope my screen is visible now. To introduce myself, I'm Elif Meriç and I'm working with Huawei as a cloud engineer right now. Also, I am graduated from Istanbul Kültür University from Computing Engineering Department in 2022. And we have 2 years of working experience as a cloud engineer. So today we will talk about Huawei Cloud Big Data Services and their practical implementations on Huawei Cloud. So let's start with our demonstration today. Mm, So as you can see from here, is our Huawei Cloud console. We will mostly focus on Huawei Cloud Web Radio Service today. Our demonstration topic is using sync jobs to process OBS data. To introduce OBS and what is OBS is the Huawei Cloud object storage service. We can store our data in the service. It can be all kind of data. But today we will use parallel file system. Its difference from the object as per service is sorry. Their difference is we can just store our files in parallel file systems, but we can store our objects in objects in OBS service. So I have created a bucket named MRS demo data. Here you can see two folders in it. One of them is Spring and the second one program. In program we have our jar file network.jar. Our scenario for today is counting our uh, files and words with this program. Then in the Flink folder, we will have this text file to count the words from it. Just let me show you. Here is our text to count the words. We will use this as an input. So our output will be stored in this folder. So let me just show you the web video service console. To talk about what is map radio service and what's its function, actually shortly we can create Hadoop clusters quickly with this service. For example, when I click this right cluster button, I will go to this console, then I will quickly create clusters according to my aim. For example, if I want to perform real-time analysis cluster, I can just click on this one. It will include Hadoop, Flink, Kafka, Zookeeper, etc. components. Or if I want to create a ClickHouse cluster, I can choose this one, or Hadoop Analysis cluster and SSP cluster, etc. But if I don't want to create one of these ones, I can just click this one, custom config, then create custom clusters according to my wish. Sorry. For example, I clicked this analysis cluster and I can just select one of these ones. For example, I can just select the Flink component. It's according to you, actually. Then for this demonstration, I will click this real-time analysis cluster because it already includes Flink. Then I can choose availability zone in this part. Then my enterprise project and VPC. You can just think of VPC as a virtual private cloud in your cloud, is a isolated area in our cloud. Then I will choose my VPC. I have already created it. And I will choose my subnet, named subnet Elif. In this part, we will see the cluster node. We can choose our node count, and billing mode pay-per-use is more effective for us, or node groups. And we can just configure the system disk and data disk in this part. For example, you can see the master node type in here, etc. If you want to enable Kerberos authentication, you can just enable it. But for this scenario, we don't need this. Username is admin, and I will set the password in this part. And for secure communications, I will enable this option. Then just click on Buy Now, and MapReduce service will create a real-time analysis cluster for you. So we perform this operation just a few clicks. So it's very easy for us with the service to create Hadoop clusters. So you can see your active clusters in this part. For example, I have already created a MapReduce cluster in here. You can see the dashboard, monitor, and notes, components, alarms, and files jobs tabs in this part. For example, in dashboard, we can see all of the information about our cluster. For example, our network information. We can see the subnets, VPC, our cluster's elastic IP, and security group, etc. After you create your cluster, you need to perform some runtime management. For example, you need to configure this MRS manager from this tab. Also, you need to synchronize your IAM user. And also, for this scenario, you need to add this OBS agency, because you have access to your OBS to retrieve data and send data to your OBS bucket. Then just click on this access manager. After I click on this one, I can assign an elastic IP from this part. I have already assigned it, so you can see it in this part. So just click OK. I will log into my MRS manager. As you can see from this console, is different from Huawei Cloud Console. It's named as Fusion Insight Manager. So you can see our tools from here. So I will click on this one and click on the download client. I need to download my MRS client to access our cluster. So after I download and install it on my master node of my cluster, I can just perform my operations. So just let me connect to my cluster. Since these operations are client installation operations are very long, I cannot show you the installations, but you can find documentations about that in Huawei Cloud. So let me firstly go to my, I will change my user to OAM for this demonstration. Then I will go to my client installation directory with cd command. This is under the OPT and Hadoop client. By the way, you need to be sure your user have permission to access the your client installation directory. If your user don't have any permissions to that, you can just go again to your root user, then just execute this command to make your other user as an owner of your directory. We will use chown command for that. So after executing this command, I will go to my user, then just execute this command to give permissions. This means that I will give all of the permissions to my OMM user for this directory. So after executing all of these commands and I have permission for this directory, I can perform it. So just list the files under this. For example, Flink. We have Flink folder under the Hadoop client. Let's go to the directory then. Yeah, this is better, I think. Then list the files again. We have another folder named Flink. Let's go to that. So you will see that we have examples as a default. I will go to this folder to see example programs. Okay. Then we will perform batch data processing. As you know, we can perform both batch and stream processing in Flink, but our topic is batch processing for today. So I will go to batch examples folder. You can see that we have this webfont.jar files program under the examples batch folder. So we will use this as an example. So let me just go to the files. So I will go to MRS console. You can see the jobs tab in here. As you know, we need a Flink job to execute this program. I will just click on create. Our type is Flink, but you can just select other type, but today we need to select this one. I will give it a name, MRS, test, Flink, etc. It's not important. Here is our program path. I will retrieve it from OBS because I store my data in OBS. So let me just find it. Yeah, its name is MRS demo data. Then I will go to program. I have already uploaded all of these required files to this OBS, so I can see all of them. Then I just click on this and select this one. And after that, click OK. Then you can see the paths. It will retrieve the program from this paths anymore. Then just give the parameters. We will give the input and output parameters to our job. Our input is, as you know, Flink, MRS Flink test. It was this one. It will count these words. So our output parameter is this output folder. It will save the output after it processes all of these data. So we can see the outputs in this folder. So that's all for that. You can just see the command reference from here. Then click on OK. And after that, you can see your job, your Flink job in this. You can see a status, etc. And we can also see the logs or the job details under the operations column. So let's go to the this console again. I will go to my Web factory named OPT group client. Then I will execute this command to process my data and also execute this work concept jar. Then just execute it. Sorry, I need to execute this command to use all of these Flink asset clusters. Source big data underscore and environment. And now it's running. So you can see this one. Job has been submitted. After it's submitted, you can see your file in OBS. Our output file. I will download it to show you. So as you can see, it counts every words in this text file. For example, this there's only one this is here, and also that there are two that and one test. So its logic is counting all of these words in this sentence. So we have performed this operation with our word count object and Flink job by creating a Flink job. Also, we can also see our logs in this graphical user interface. So let me go to our Fusion Insight Manager to show you. So here we can see the cluster tab. I will go to services. And under the services, you can see this yarn. So you can see this resource manager web user interface section. I will click on the active one. And you can see all of your applications. This last one is my application that I executed it, recently executed. Then you can see its state and final status. You can see it's finished and succeeded. Just go to this one. And we can see all of the information about our task and also logs. For example, we can see the permissions or the other logs about our application. That's all for my part, actually. If you have any questions, we can answer them with Hakan in question and answer section. Thank you for your listening.
Thank you very much for practical side, Elif. This example is important to big data side and example of the basis of the Flink and OBS. Watching people, if you have any question, we will be happy to answer. If you have any question about the video after the broadcast, you can send an email to HTG to share it. And we are waiting for your questions right now. Elif, and thank you very much for your understandable explanation about the Huawei Cloud site. So basics of that is so easy to understand and easy to use of the things. So you will be explained very good. Thank you very much for all your part.
But, also thank you for very much for your all of it. Thank you.
So I think we will be finished this session.